Saxon Algebra 1, Lesson 69, greetings students, factoring trinomials. This is a big lesson, you guys. You probably know more about it than you think you do, but this is something that we're going to be building on and using as part of other problems for a long, long time to come. So let me start by showing you something that probably looks somewhat familiar. This is a pair of what we call binomials. We're used to seeing things in parentheses like this. We know that these are quantities that have a letter and a number and either a plus or a minus sign in between. And we know how to multiply them. We know that if you stack them, you can do a thing that I like to call the dance. You imagine these as boys, these as girls, and they're going to take turns dancing together. We start with this girl, she dances with each boy, and we write their products down below. X times x is x squared. X times 5 is 5x. It's positive. She's done. She sits down. This girl's turn. She does her multiplications. Okay? We call this multiplying binomials. Okay? Then the answer that we get, which when we add these, we call this a trinomial. It now has three parts, doesn't it? An x squared, an x, and a plain number term. We can also call this a quadratic expression. We can put a 0 on it, a quadratic equation. We can also call it a quadratic function. We'll call it all of those things, but right now we're just calling it a trinomial. And what I want you to see, and what we're going to focus on in this lesson, starting in this lesson, is that we can take a trinomial and go backwards to find the pair of binomials that created it, right? So we started with this, we go to this. From here, we know how to go to this. But now what we're going to learn is how to go back, and we call that factoring trinomials. And just remember, trinomial is one name for this thing. There are other names, but we're going to be able to take it back into that form. So we'll be able to go back and forth between these two forms any old time we want. And trust me, we're going to do a lot. All right, now there are a couple simple rules that we do use. Well, let me say this first. There are three ways. I'm not going to tell you them all today, but what I'm going to tell you is the first way. 3 ways to factor a trinomial, okay? So there's multiple ways to go from here to here. One of the ways only works for certain kinds of trinomials, and that's one we're gonna work on today because it's the easiest. We call it factoring by inspection, which means simply we just look at it, okay? And we'll be able to figure out how to factor it. So what I'm going to do is cover this one today. We'll be covering these other two as we go, and you'll in the end know 3 ways to factor a trinomial, or as we'll start calling them later, quadratic. I just want you to hear that word so that later when I throw it at you, you won't be like, what are you talking about? It's a trinomial. Yes, it is, and it's something else too. Okay, 69. Just a second. I'm going to do 69.2 first because that's the one I used in the example. All right. And it says to factor x squared plus 3x minus 10. okay? And we're told the word is factor. Factor means to break it down into the pieces that multiply to equal this, okay? This is a product and we want the factors. We want the pieces that we multiplied to get the number. And here's another version of what I just drew for you. These are the factors. This is the product, okay? You can remember that because we multiply the factors to get the trinomial, and then breaking it back down into its binomial pieces is called factoring, okay? It's not division exactly, so we don't call it dividing, but it's similar. It's the opposite of multiplication. Okay, so here's what we do. We draw two binomials because we know that's the shape our answer is going to take. In these examples that we'll be working for a while now, we'll always have a plain x squared right here. We will never have a numeric coefficient other than the invisible 1 that's always there, right? So in our binomials, we can automatically put in an x. That part is automatic. Now, there are two rules that we're looking for in finding the numbers and signs that go here. The first thing we do is, let me write it. Before I read this, let me say that I skipped over the part of reminding you that this should always be put in its proper order. X squared, plain x, plain number, right? So we always put the in order first. I think it's gonna be a while before John, oh no, he throws that one at us really soon. So we'll get to that in a minute. Okay, so what we do is we write down pairs of numbers that multiply to the last term, including the plus and minus signs. All right, so what are some numbers that multiply to -10? Well, there's -1 and +10, and there's +1 and -10, and then 2 and 5, right? We could do -2 and +5, or we could do +2 and -5, all right? Eventually, we'll carry this work in our heads, but for now, I want you to write it down. Then the second step right? I'll give you a second to finish writing. In the first step, we wrote down pairs of numbers that multiply to the last term. In this one, we look for the pair among these that adds to the middle term. And by that I mean the numeric coefficient of the middle term. I didn't write all that down. I was afraid you'd scream. But the number, right? So we're looking for a pair of numbers that multiplies to -10 and adds to +3. So we can right away dismiss these because we know these do not come up with a difference of 3. And then we know it's between these two. This one, when I add them, I get -3. This is the one that gives me +3. So then, the final step is what I call an art project, because all we have to do is make it look nice. We take these two numbers with their signs and we write them here. Order does not matter. We don't have to put the big number first and the little number second. We don't have to put the positive first or the negative second. There's no rules because, as you know, in multiplication, order does not matter. This is just to remind you that that's the number we were going for. All right, so this is our answer. As you can see, once we stop writing down steps and big definitions, there isn't a lot of work to show, right? You list the pairs and then you just circle the one that works and then you do the art project, all right? Most students find this really fun because it's like a little puzzle trying to puzzle these out. So now we're going to do 3 more. I did example 2 first because those were the numbers I used in my explanation. So I wanted to show you right away. And look, it did take us right back. Our answer was this. We wrote it in the opposite order, but our answer was that exactly. All right, so that's factoring trinomials. We're going to do lots of them. Remember that before we can factor, we have to get it in the proper form. X squared, plain X, plain number. Okay, so let's go back and do 69.1. And let's see, the expression for this one is x squared minus 14x minus 15. Okay, numbers that multiply to this and add to that. We know it's going to look like this. We know there's going to be an x. We don't know the sign and we don't know the numbers. So let's list things that multiply to minus 15. Negative 3 and 5, negative 5 and 3. I'm writing this in a different way than I wrote it before. It doesn't matter. I can immediately see that's going to be plus 2, that's going to be minus 2, no bueno. What about 15 and minus 1 and minus 15 and positive 1? Oh, now we're getting someplace. This is our pair, right? Because this does multiply to minus 15 and it adds to negative 14. So, art project, and guess what? That's the right answer. Because it's so easy to get twisted and turned around, I recommend that for the first couple weeks that we're working these problems, write down your list. The only time students ever mess up these problems is when they try to carry too much of this work in their head, not only the listing of the pairs, but then trying to add them in their heads. It's easy to get turned around and choose the wrong pair. So please, do us all a favor and just write down the pairs. It's just a little list. It's no big deal. Okay, John gives us a mess. And so I want you to always be on the lookout for this kind of nonsense that he creates. He likes to do that with quadratic expressions / trinomials. He likes to mess them up just to see if we're paying attention. So we just put it in order. We're fine. We set up the art project. We can write in the x's, things that multiply to 6. Now, this is a great example of one where you can get turned around so easily. We're multiplying to positive 6. So that means it could be 2 and 3. It could be minus 2 and minus 3. It could be 6 and 1. It could be negative 6 and negative 1. All of those multiply here. Now, what a lot of students will do is they don't write it down and they think, oh, it's negative 6 and positive 1, right? Because they think it's going to be something like this. But that doesn't work because negative 6 and positive 1 give you negative 6, not positive 6. Do you see what I'm saying? The minus signs, if you're not thinking clearly, the minus signs can trick you into going down the wrong path really easily with certain numbers. So write them down. And we see here, oh, this is positive 5. This is where we get the negative 5. The 6 and the 1, even though the difference between 6 and 1 is 5, a lot of people try to create rules that allow them to shortcut this, but it doesn't work in this case because they're either both positive, where that would be positive 7, or negative 7. It's not a plus minus situation. So this is our pair. You might not have followed everything that I just said. All I'm trying to say is write down your pairs and work carefully. Minus 2, minus 3 is our art project, and that's the right answer. I have not been smiley facing my answers. You know what that means? I have to start the whole lesson over. JK. This was right also. Okay. All right, as you can see, if you're writing like a normal human and not like a teacher who's trying to make people see what she's doing, you can do these in very little space. They're not long, complicated problems. Okay, one more. I'm gonna scooch it in a little bit. Ready? It is, once again, John's playing games. X squared plus 5 plus 6x. I'm writing it down the wrong way to make a point to you, but here's the thing. If I was a student doing my homework, I wouldn't waste my time writing it down in the wrong order. I'd fix it as I wrote it down. You're certainly invited to do that. So I wouldn't even write that. I'd write x squared plus 6x plus 5. You might not feel it as strongly now, but soon this will just become so jarring to you to see it out of order. Okay, we set up our binomials. We know there are x's in the beginning, and we write our pairs. 5, well, there's only one way to get positive 5. Well, I mean, one set of numbers, right? 5 and 1 is 5. Negative 5 times negative 1 is 5. We want positive 6. So it's there. So we do plus 5, plus 1. Our project is done. Yay! Oh, factoring trinomials is going to be our life for quite a while. The good news is most students find it to be pretty fun. Once those rules settle into your brain and you feel comfortable with them, these problems are kind of fun because they're like little puzzles that you get to work out. Eventually, we're going to learn, let me go back. Eventually, we're going to learn 2 more ways to factor what we're now calling trinomials, what we'll later call quadratics. And you'll look back on this, the inspection method, and go, oh, that was so fun. I love doing that. Okay, so trust me, you're gonna have warm feelings about factoring trinomials by inspection. And you're going to have warm feelings because this is the end of today's lesson. I don't know, maybe you'll miss me when I'm gone. I don't know, you have to go do your homework, so you probably will miss me. Okay, I'll see you for lesson 70 though, and that is completely different. It has nothing to do with algebra, and it's a nice little mental break. See you then. Goodbye.